Let's try some problems asking, is y a function of x? Given an equation with x and y, determine if y is a function of x. So for this one right here, the main objective is you want to try to set y, you want to get y by itself, and a lot of times that'll tell you your answer. So I'm going to add y to both sides, and I'm going to subtract 2 from both sides. And now I can see that this is just the v, and it's moved down 2, so that it is a function. Because when I plug in a value for x, like let's say 1, I'm going to always get -1 for y. When I plug in 3 for x, I'm always going to get +1 for y. When I plug in -1 for x, I'm always going to get -1 out for y. So yes, it is a function. This one right here, again, it maybe looks a little confusing, but just solve it for y. So let's subtract this from both sides. Y equals 4 minus x minus 2 squared. And that might look kind of crazy and difficult to tell or to see what that is, but if you distribute this out right here, all you're going to get is some equation like x squared plus something x plus something. When you add like terms, it's just a quadratic equation, and we know quadratics are parabolas, and that passes the vertical line test. So yeah, this is a function, meaning again, when you plug in something for x, you're always going to get the same answer out for y. How about this one? Well, this one you can see something's going to be a problem, because you see that there's a squared over the y. So when you try to set this equal, when you try to solve it for y, you're going to first have to subtract x from both sides. Then you're going to have to take the square root, and when you take the square root, that's where you run into all kinds of issues, because the square root, whenever you take it, you have to put a plus or minus sign in front of it. So that squared is gone. So y now, when I subtract the 1 from both sides, y equals -1 plus or minus the square root of -x plus 1. And you can see now when you plug in say 0 for x, what are you going to get out for y? You're going to get the square root of 1. That's what you're going to get. You're going to get -1 plus or minus 1. Well, what's -1 plus 1? 0. And what's -1 minus 1? -2. So there's 2 points. When you plug in 0 for x, you can either get 0 out or you can get -2 out. And that's why that's not a function. When I plug in 0 for x and 0 for y, that works. But also when I plug in 0 for x and -2 for y, that also works. Either one of those will work, which means not a function. Try another one. Is y a function of x here? Again, this might look confusing, but we don't have any problems. Not only because this is a cubed, even if this was squared, we still wouldn't have any problems. Because the y right here, to get it by itself, I just subtract 3 and divide by 2. And all that is 1/2 x squared minus 3/2, which is just a parabola. It's just a quadratic equation. And so there's no problems. When I plug in something for x, I always get a consistent number out for y. If I plug in 0 for x, I have to get -3/2 out for y. If I plug in 1 for x, I have to get -1 out for y. If I plug in 2 for x, that'd be 4. 2 squared is 4, divided by 2 is 2. It's 1/2. I get 1/2 out for y. I don't get something else sometimes. Whenever I plug in 2, I always get 1/2 out. So that's what it means to be a function, and that's why when we create a lot of times it's good if you can visualize what a function looks like. That function right there is a sideways parabola. Sorry, sideways v. That function right there is an up and down v. That's why you learn how to graph equations and basic graphs. Y equals x squared is a parabola like this. X equals y squared is a different kind of parabola. So if I had y squared equals x, now what I did is I just flipped that parabola on its side like this, which is not a function because the vertical line test. There's two values there are 2 points that have the same x value, namely whatever's right there, let's say 3, and different y values. That's why you've got to be careful when you're doing these problems to know what graphs look like and understand that.